Starting. All right, hey everybody, Mr. Donnie here, looking at the Chapter 4 problems. Let's just go over. So it says of the species below, only blank is not an electrolyte. So you just got to remember, an electrolyte would be any ionic compounds, because that will ionize, that are soluble, they'll break up into ions and conduct. But also acids and bases are going to be electrolytes, because when they dissolve, they break up into H plus and whatnot. So that gets rid of HCl, that gets rid of KOH, that gets rid of NaCl. And this Rb2SO4, well, I don't remember if that's soluble or not. You could cheat and look at your reference tables, which is, here they are. And you can look for the solubility rules on table F. But hopefully you'll start to just kind of remember them. So go back to the PowerPoint. SO4 is what we're looking for. I find SO4 down here. Oh no, you didn't, smartboard. You did it again. You dirty guy. All right. So find SO4 right there, and it's soluble except when combined with one of these guys. So I go back to my problem and I see that it's not an exception, so it will dissolve. The only thing that won't dissolve will be argon, right? Because it's a noble gas. It's not going to break up and conduct. It's a non-electrolyte. All right, so we take a look at number 2. So the balanced molecular equation for the complete neutralization of H2SO4 by KOH in aqueous solution is blank. So since we're talking about the molecular equation, we're not doing the net ionic. We want to know what the actual molecules are. So we're going to start with H2SO4 and KOH as a reactants. So that gets rid of A and B real quick. And now we got to look, all right, well, what are we going to end up with? Well, here, that's an acid and a base. So we should definitely end up with water. All right, well, that's narrowed it down to, it has narrowed it down, huh? Well, we're going to get water and a salt. So we take a look. We're going to get choice E. Now, they're pretty similar to each other, aren't they? Everything's the same. That's the same. That's exactly the same. This is exactly the same, but the difference is right here. And the S means solid, the AQ means aqueous. And I know my rules for group 1 ions, they're always soluble, no exceptions. So I know that this is going to be dissolved in water. So that gets rid of choice D. Choice C doesn't work because we should end up with, that's not right there. That's wrong. All right, take a look at number 3. It says, which of the following is insoluble in water at 25 degrees Celsius? So a couple things just right off the bat to remember. Anything that's in group 1, always soluble. That's easy enough to memorize and see if that helps out. That gets rid of choice B, right? Other things that are always soluble would be, let's take a look. Let's cheat again. NH4 is always soluble. NO3 is always soluble. So it's probably easiest just to memorize which ones are always soluble, because then you can eliminate half the problems right there. So we take a look. All right, MgPO4. Well, let's see if we can find anything. I find the PO4 is always insoluble except when combined with group 1 or ammonia. So I go back and look at my problem. That's not group 1 or ammonia. So that's choice A right off the bat. All right, if we take a look at our solubility chart again, ammonia is always soluble, so I know it can't be that choice. I look, all right, I could find hydroxide on that chart as well. Hydroxide right there, and it's insoluble except when combined with those. Hey, look, it's an exception, so that one's soluble. And then same thing with choice E. We find that acetate ion, which is right here on that table. Check out the solubility rules. Acetate, always soluble, no exceptions. Cool. Number 4, it says a weak electrolyte exists predominantly as blank in solution. Well, let's eliminate some things that are probably easy to eliminate. If we're talking about electrolytes, we're talking about ions, molecules, compounds. We're not talking about individual atoms. We're not talking about electrons or isotopes. So narrowed it down to B or C. So if we have a weak electrolyte, what happens is we have most of it, we have this equilibrium, right? Between it is the molecule or the compound, and on the other side of it, we have the ions, right? That it breaks up into. Electrolytes that break up and have mostly these things are called strong electrolytes because they strongly break apart and will conduct electricity, whereas weak ones will favor the molecule, the undissociated, the still stuck together stuff, which would be choice C. They're still a molecule because they're weak. They hardly break apart. They stay mostly as molecules. On to choice 5, or problem 5. A strong electrolyte is one that blank completely in solution. This one's just kind of a definition question. You got to know what a strong electrolyte is. It doesn't react. It doesn't associate. It doesn't disappear. It ionizes completely. It breaks up completely. So instead of, if we had a weak electrolyte, you would see this double arrow saying that, hey, it goes forward and backwards. It's in equilibrium, and it breaks up into H plus and A minus, and that's for a weak. But if you had a strong electrolyte, it would just say, hey, it starts off as one thing and completely goes to ionization. On to problem number 6. Which of the following are strong electrolytes? This one, you got to kind of start committing things to memory. All right, so we know hydrochloric acid is strong acid, so we know that that's a strong electrolyte. All right, we know KCl is completely soluble, so that's a strong electrolyte. This one, the acetic acid, is a weak acid, so it's actually a weak electrolyte because it'll stay as a molecule. And same thing with NH3. It's a weak base, so that gives us choice A. Number 7. Keywords here. It says the net ionic equation for the formation of aqueous Ni2 accompanied by the evolution of CO2 via mixing solid NiCO3 and aqueous hydroiodic acid. So a lot of words here. Let's write the chemical equation, the molecular equation, to figure out what's going on. So what are we starting with? Well, from reading it a second time, I know that I'm starting with the NiCO3 and the hydroiodic acid. So if it's hydroiodic, well, you know it's H and I, and that's our acid. So we're adding those two things together, and we're getting Ni2, or NiI2, and CO2 as well. So this isn't balanced. I'm not going to balance it right now. I'm just going to try and figure out what the net ionic equation would be. So you go, all right, well, am I missing something? I'm having a brain fart, right? Where'd the H go? Anyway, brain fart, Donahue, you suck at life. I know, stop yelling. All right, so if we take a look at what can we eliminate from the net ionic equation, well, we can get rid of a couple of things, right? We have nickel. This is going to be soluble. So we got Ni plus 2 and CO3 minus 2. Hydroiodic acid, it's an acid, so you know it breaks up into H plus and I minus. And we got nickel iodide and CO2. All right, so we have that's formation of aqueous solution of Ni2. The thing that we're missing, Donahue, is H2O. My bad. Aqueous solution. So we got some H2O in there. That's where the hydrogen's going. All right, well, what's soluble, what's insoluble? I know NiCO3 is soluble, HI is an acid, soluble. So now I got to figure out, well, what about nickel iodide? I can cheat and go to my reference tables and look for iodide. Doop-a-doop-a-doop. Halides right here. right? They're always soluble except when combined with that, so that's not an exception. So this is soluble, so we're going to get Ni plus 2 and I minuses because it's soluble. Well, what doesn't change? Well, I know I got I minus on both sides, so that's what we call a spectator ion, right? I got H. Oh, I'm sorry, no, I got H plus on one side, right? Still, but then it ends up in a molecule, so we know that that's going to stay. We're going to have H plus. It's going to end up as H2O. And then solid. That was a solid initially, and now it's dissolved. So it's no longer just a solid. It's going to break up into Ni and CO3 eventually down there. CO3 changes. Man, I just butchered that one, huh? Sorry, guys. I should just erase and start over. What am I going to do? Erase all this, start over. Mr. Donahue, yep, I know. Stop yelling. So I start with this as a solid. It says HI, the acid. That's going to be aqueous. I end up with aqueous NiI2 and CO2 and water because it's all aqueous. So there's H2O. Well, I know that since this was a solid to begin with, that if it ends up as an ion because it's aqueous, well, there's a change there. So I'm going to have to keep that. If this was aqueous, I got H plus and I got I minus. Well, over here, that means I also have Ni plus 2 and I minus. They're not actually stuck together. They're dissolved. I got I minus on both sides. So that's not going to be part of my net ionic equation. All right, so I know I'm keeping the NiCO3. It doesn't help me a whole lot because all the options have NiCO3 as a possibility. All right, well, what's different? Well, I can get rid of this one now, but I can get rid of B because I minus isn't going to stick around, right? CO2 is a gas that wasn't there initially, so I know I'm going to need that in the products. That doesn't help me because it's all there. Going to need H2O, right? Because the hydrogen ends up in the H2O, so that changes. And nickel goes from being part of a molecule, ends up as an ion. Choice C. All right. Number 8. Which combination will produce a precipitate? This is just kind of remembering your solubility rules or cheating if you don't remember. So, all right, I look at choice A. What's going to happen? Well, they're going to switch partners and see what happens. I'll get PB. I'm not going to write there. I'll get PB and Cl with H and NO3. They switch partners. Now, I remember the NO3s are always soluble, so I know that that isn't going to be my precipitate. But I kind of remember seeing PB somewhere. So I'm going to look. I find lead. I look for chlorine. Found my chlorine right here, right? And it's soluble except when combined with PB. So that's insoluble. All right, so the choice is A. But why don't we take a look at B, C, and D to check. I take a look at B. I know NO3 and acetate ions are always soluble. So I know can't be that. Mix them up. They're still soluble. KOH and HNO3 is going to give me water and potassium nitrate. All right, this isn't going to be a precipitate because it's water. It's not a solid. And this is soluble, so that's not going to be a precipitate either. Take a look at choice D. And again, it's 2 acetate ions, so even if you switch partners, you end up with the exact same thing. You're going to have no reaction there. And then if you take a look, we have Na is always soluble, and NO3 is always soluble, so you switch those up. They're going to be soluble. And then we got to check, well, what about this OH? All All right, I'm going to cheat. I look for my hydroxide. It's always insoluble, except, hey, wouldn't you know it, that one's an exception. So they're both soluble. All right, there are more for this one. Problem 9 says, what is the net ionic equation for the reaction between aqueous nitric acid and aqueous sodium hydroxide? All right, well, I have strong acid plus a strong base. Will always give you a salt and water, right? And the salt, if it's soluble, is just going to drop out. For strong acids and bases, it's always H plus OH minus gives you H2O. So that would have to be choice C, right? 10. Balanced net ionic equation for precipitation is calcium carbonate when aqueous solutions of sodium carbonate and calcium chloride are mixed. We actually did this problem. We did this in the lab. We took Na2CO3 and we reacted it with calcium chloride to give us CaCO3 and NaCl. All right. So this is our precipitate. This became the solid. This was aqueous because we did it in solution. Both of these were aqueous when we started. All right, well, I know that I can get rid of the things that stayed aqueous. So I can get rid of the NAs, I can get rid of the CLs. So now I can just look at what happened. What happened was I had calcium ion, I had the carbonate ion, and it gave me a precipitate, calcium carbonate. That's our net ionic. That's overall what changed. So what option matches that? Option D. All right. Which one of the following is a weak acid? Oh, this is 4.3 going too far. We're done with 4.1 to 4.2, ladies and gentlemen. I hope you found this helpful. You know, come to class for questions. All that good jazz. All right, now I got to close this. Go hang out.